You know, every year people are killed or seriously hurt on railway job sites. And the truly tragic part? A lot of these incidents, they're completely preventable. It really all comes down to understanding one core idea. The ground beneath your feet changes with every single type of track. And if you don't change your safety rules along with it, you're in big trouble.
And that's it. That's the single most important thing you have to burn into your brain. Whether you're working on that classic crushed stone ballast, a smooth concrete slab, or a high-speed line, each one has its own unique set of traps waiting for you. Think about it. Treating a high-speed line with its invisible air pressure waves the same way you treat a regular ballast track, well, that's a recipe for disaster. This safety gear and rules that keep you safe in one place can be totally useless or even get you killed in another. The stakes are just way too high. You absolutely have to know the specific dangers of each environment.
Okay, so here's how we're going to break this down. First, we'll look at what makes the railway such a uniquely dangerous place to work. Then, we'll get into a really powerful framework for managing risk called the hierarchy of controls. After that, we're going to apply that framework to 3 real-world case studies: ballast, ballastless, and high-speed rail. And then we'll wrap it all up with the one thing you need to remember.
Yeah, railway construction. It's just not like any other job. It's this dynamic, live environment where the biggest dangers are often invisible, silent, and can have immediate, fatal consequences. Losing focus for just a second out here isn't a small mistake. It can be absolutely catastrophic. So what are we really talking about here? Well, first you've got your electrical hazards. Those overhead lines are carrying a massive 25,000 volts and you don't even have to touch them. The electricity can literally jump through the air to get to you. Then you've got kinetic hazards, and that means trains, which can show up almost silently and at full speed. This is why a possession breach, which is just working outside your approved time or zone, is so incredibly deadly. And finally, you've got the environmental stuff. The ground itself is trying to get you. Unstable ballast stones, hidden ditches, they create these constant trip hazards right next to a live track. So, with dangers this serious, how do we even start to manage the risk? Well, we use a proactive framework, and it's called the hierarchy of controls. And it's not just some checklist. It's a smart way of thinking that ranks safety measures from the most effective all the way down to the least effective.
So right at the very top, the best option is elimination. Just get rid of the hazard completely, like shutting down the power to the line. Next down is substitution, replacing something dangerous with a safer option. Then you've got engineering controls, which physically separate people from the hazard, maybe with barriers. Below that, administrative controls, which is all about changing how people work through rules and procedures. And right at the bottom, your last line of defense is PPE, your personal protective equipment. The key thing to get is that you never, ever rely only on PPE if there's a better control higher up the pyramid. So now that we have this framework, let's see how it actually works in the real world.
All right, time to put this framework to the test. Our first case study, the traditional ballast track. You know the one, stones, sleepers, rails. It's the classic railway we all picture in our heads. Looks simple, right? But its dangers are hiding in plain sight.
So here's how the hierarchy works on a ballast track. That unstable footing from all the loose rock, ankle-supporting boots, a PPE control, are your go-to. What about tamping machines that can literally fire stones out like projectiles? For that, we use an administrative control, a strict rule about keeping a safe distance. And for those ditches that get hidden by mud, another administrative control. A clear rule that you only walk on the stable cess, that's the shoulder next to the track. No cutting corners across the stones, ever.
Okay, let's move on to our next site and see how things change. We're now on ballastless track, also called slab track. You see it a lot in tunnels and on viaducts. It's all smooth concrete and high-tech systems. But that clean look is deceiving. The dangers here aren't about tripping over rocks. They're about the sensitive technology that's built right into the concrete. On a ballastless track, dropping a single steel wrench near a signaling sensor could cause absolute chaos for the whole system. So the best control is substitution. Just swap out that metal tool for a non-metallic one. Simple. For the risk of falling off a viaduct, well, that's where PPE is non-negotiable. You're wearing a harness, period. And to make sure you don't accidentally drill into some critical system embedded in the concrete, that's a strict administrative control. You get explicit, written permission before you even think about starting.
And now for our final case study, high-speed rail. Okay, this is where the game changes completely. The main danger here isn't just the train itself, it's the incredible speed of the train, which creates a whole new set of invisible, deadly forces you have to deal with.
We're talking about speeds of up to 350 kilometers an hour. At that velocity, a train doesn't just pass you,
It fundamentally changes the air around you. The air itself becomes a weapon.
That air pressure wave from a passing train, it creates this powerful vacuum that can literally suck you right onto the track. The only real defense is in engineering control, designing the line from the start with refuge spaces much closer together, maybe every 50 to 100 meters. And the risk of a dropped tool? Here, it's not just a mistake, it's a potential projectile that could derail a train moving at incredible speed. That demands an ironclad administrative control. Every single tool gets logged in and every single tool gets logged out. No exceptions.
So, what have we learned here? We've looked at 3 totally different environments and the very specific rules they require. The last, and honestly the most important step, is taking all of this and turning it into a single practical rule for every day you're on site.
This right here, this is what a good safety briefing sounds like. It's not some generic talk. It is a precise tactical plan for the day. See how it starts? By identifying the exact track type. Then it clearly names the top 2 or 3 hazards for that specific place. And finally, it lists the exact controls everyone must use, from their PPE to the procedures. This is what putting the framework into practice really looks and sounds like.
And this is it. This is the big takeaway. A safety plan for a wobbly ballast track is useless on a high-speed viaduct. A tool rule for a tunnel makes no sense on an open line. There's no such thing as one-size-fits-all safety. The only plan that works is the one that is tailor-made, specific, and right-sized for the ground you are standing on right now.
So I'll leave you with this last thought. Before your boots even hit the ground, before you pick up a single tool, what's the very first question you need to ask yourself and your team? It's a simple one. What kind of track is this? Because the answer to that question changes absolutely everything.